So in this problem, we want to find the relative max and the relative min of the function f of x, which is defined by x plus 4 over x minus 2. So relative extrema can occur at critical values. So we're going to need to find the derivative of this function. So before we find the derivative, let's write it as x plus 4 times x to the negative 1 plus 2. Because then when I take the derivative, I can use the power rule a little bit more easily. So the derivative of x is 1. Then for the derivative of the second term, 4x to the minus 1, we bring the minus down to get negative 4 times x to the negative 2 by the power rule, plus the derivative of 2 is 0. And let's go ahead and write that with a fraction again and write it as 1 minus 4 over x squared. And we want to find critical values of this function. So critical values occur where the derivative either equals 0 or where it is undefined. So if we set this equal to 0 and solve, then we get 1 equals 4 over x squared. Multiplying both sides by x squared, we get x squared equals 4. So x squared could equal positive or negative 2 are two critical values of this function. Now the derivative also is undefined at 0 because you would be dividing by 0 if you plug in 0 into x squared. So f prime is also undefined at x equals 0. However, the original function is undefined at 0. So this actually has a vertical asymptote at x equals 0. So it doesn't make sense to call it a critical value because it's not even a part of the function anyways. Okay, but f is also undefined at 0. So I'm not going to say 0 is a critical value. Okay, so the extrema then, relative extrema, could potentially occur at positive 2 or at negative 2. Oops, I put a little square there. I shouldn't have. There we go. So in order to tell if they are extrema, there's two ways. We could use the first derivative test or the second derivative test. I'm going to use, I think, the first derivative test here because I'm going to also use the fact that we have a vertical asymptote at 0, vertical asymptote at x equals 0, and put that on my chart when I do the first derivative test. Okay, so for the first derivative test, we want to put our critical values and anywhere where the function is undefined onto a number line. So I'm going to put negative 2, 0, and let's make that a little bigger, and 2 all on this number line. And I want to plug into the derivative. I want to plug some test values into the derivative. Those test values need to come from somewhere in between negative infinity and negative 2, somewhere between negative 2 and 0, between 0 and 2, and between 2 and infinity. Okay, so my test values that I'm going to choose to plug into the derivative, I'm going to go with negative 3, negative 1, 1, and 3, just for simplicity. So I want to plug into the derivative here. So f prime is equal to 1 minus 4x squared, and that is what I'm plugging into right here. So f prime of my critical value. And actually, you know what, it will be easier to plug in to that version of the derivative right there, 1 minus 4 over x squared. And all I need to see is if the derivative is positive or negative at each of these 4 x values. So when x is negative 3, we square negative 3, we get 9. 1 minus 4 ninths is positive because that's 9 ninths minus 4 ninths, which is a positive number, is greater than 0. And I'm going to get the same thing when I plug in positive 3 because 3 squared is also 9. So f prime of positive 3 is also greater than 0. And if we plug in plus or minus 1, negative 1 or positive 1 squared is positive 1. So we'll have 1 minus 4 or a negative value, negative 3. So the derivative is negative at both of those x values. So that tells us that f is, because f prime is positive, the function is increasing on the interval from negative infinity to negative 2. And then because f prime is negative, f changes to decreasing on the interval from negative 2 to 0. Then we have that vertical asymptote at 0. the function is still decreasing after 0 and then increasing again after 2. So it appears that we have a local or relative max at x equals 2 because the function changes from increasing to decreasing at that x value, and we have a relative min at x equals, oops, that should say negative 2, at x equals positive 2 over here because the function changes from decreasing to increasing. And then you can go back and find the coordinating y, so let's find the coordinates, the coordinating y values at negative 2 and 2 simply by finding f of negative 2 to have your max and f of 2 to get the min. So let's go ahead and do that. The original function is right here, x plus 4 over x minus 2. So f of negative 2 is going to be negative 2 plus 4 over negative 2. 4 divided by negative 2 is negative 2. Then we have this minus 2, so it looks like we're going to get negative 6 for that as my max, if I did this correctly. And then for f of 2, we'll have 2 plus 4 over 2 is 4, minus 2 is 2. So f of 2 is 2 as a relative min.